Hello kids, welcome to a presentation on subtracting fractions. I'm going to go ahead and start with common denominator first and then go without a common denominator. So fourth graders, this is primarily for you, and a couple of things I want to go over first is how this looks different than addition. So first of all, there are certain terms in addition that we use. You add an addend and an addend to get a sum or a total, okay? But in subtraction, you have different terms. You have what's called a minuend, a subtrahend, and a difference. So these are special words we use when we talk about subtracting. So we have the minuend, which is what is going to be subtracted from. What is subtracted from is the subtrahend, and the difference is the difference, or what is left over. So keep that in mind as we move forward. So let me give you an example to start. And let's just use whole numbers. There's my equal sign. There's my subtraction sign. I'm going to do two wholes here, and I'm going to take away one of them. So what I'm going to do is I'm going to build my subtrahend from my minuend here to get my difference. So with addition, it would be very simple. We would have one whole plus one whole, add them together, and we have two wholes here, right? Well, that's not how it works with subtraction. Subtraction, we're going to have two wholes, and we're going to write down the problem here. 2 minus 1. So we're going to take the subtrahend from the minuend, put it here, and whatever is left over will become our difference. So again, to review, let's do it even more here. I can even do it like this. If I have just whole numbers from this fraction, this is 4 and 1/3 minus 2. So here's the problem, 4 and 1/3, so this is a third. Show you guys it's a third. So I have 4 wholes and a third, but I'm going to take away 2. So I'm going to build my subtrahend from my minuend, and what's left will be my difference. So I'm going to take away 2, okay, put those here, and what I have left over here in my minuend is going to be my difference. So I'm going to bring those over here. The difference between the two is, in fact, 2 and 1/3. Okay, so that's how it's going to work. It works a little bit different with the concrete materials than when you do addition, but that is just a basic sort of overview of what's going to happen there. Well, the first thing we're going to do is give you a couple of examples of what happens when you subtract from things with a common denominator. So I'm going to use some, and I feel bad that I did this. There we go. Should have taken some of these out that I wasn't going to use. But these are some parts of our geometric cabinet. Let's go ahead and start with this one here. So I'm going to hold this up to you guys and we'll count them together. So this is a whole, but it's divided into how many parts? Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Oops, sorry about that. So that is a whole that is divided into 8 parts. So let's put the whole out here as our minuend. And I can't necessarily say our bigger number, because once you start getting into negative numbers, you might have a minuend that is smaller than your subtrahend. Then you're in a different arena, going into negative numbers. Reminds me when I was a kid playing Super Mario Brothers. You could go into minus world. Very exciting times. All right, so we've got our whole here, and this is going to be 8/8 But since that's only an apparent fraction, I'm going to go ahead and turn that into, let's do 7/8. So I'm going to take 1 out. So my starting number is going to be the fraction 7/8. So you see that? I've got 1/8 that I took out. So I'm going to write that down. 7/8. And I'm going to take away 4/8. No, I better not do that. Let's take away 1/8 from it. So 7/8 minus 1/8. All right, so there's our problem. So I've got my minuend here, and the subtrahend is going to be what I'm taking away, and then the difference is going to be what's left over here, and I'm going to transfer this over here to my difference section. So I have 7/8, take away 1, okay, and then I move the rest all the way over here, and I'm building another Pac-Man again. Pac-Man, except for he's facing kind of towards me. All right, so there's Pac-Man, he's coming after me. I have taken away 1/8, and now I have, how many 8s total do I have left? Well, let's count them. 1, 2, 3, 4, 5, 6. Hold them up to you. 1, 2, 3. That's the first set. 4, 5, 6. Pac-Man's definitely coming for me now. All right. I have 6/8 left over as my difference, and that is our answer. However, some of you may be saying, but Mr. Adam, we can reduce that. You are 100% correct, so let's do that. What number is 6 and 8 both divisible by? Let's try 2. So 6 divided by 2, 8 divided by 2. Always treat numerators and denominators fairly. 3/4. 3/4. But don't take my word for it. Let's go ahead and check with our fourth pieces here. So I've got 3/4 here, holding these up. I'm going to lay these down, and I'm going to see if, in fact, my 6/8 matches this. If this covers this completely, and it matches it, then we're in good shape. And lo and behold, it's a perfect fit. 6/8 is indeed equivalent to 3/4. So that is an example of subtracting with like denominators. I'll do one more example for you, and then we'll get to the harder work of coming up with common denominators. Put my 8s back together. All right, thank you, Force. You did your job. You helped me prove a point. Appreciate that. Let's go to the next one. Let's take a look at this one. Let's count how many are in this one. Count with me. 1, 2, 3, 4, 5, 6, 7. All right. So let's start with 5/7. Why not? Okay. So I'm going to take 5 of my 7ths out, and then leave the 2 here behind. They're not part of my problem. That's a really hungry Pac-Man. So that is 5/7. And remember, my minuend is going to be here. My subtrahend that I'm going to take away, I'm going to move here. And I think that's going to be, let's do 2/7. And that'll get us our difference. Okay, well, let's do it. Here's the rules for subtraction. Take these 2, put them here with the subtrahend, and then these move over and form the difference. And the difference is, in fact, 3/7. Can we reduce that one any more, kids? We cannot, because 3 and 7 are not divisible equally by the same number. So that, kids, is an example of subtracting fractions with common denominators. So when you get a problem like that, you are in luck, because Having fraction problems with common denominators is awesome. But you're not always going to get that. Let's talk about what happens if we do a subtraction problem without common denominators. So let's do 3 1/2 minus 1 1/5. Uh-oh. Oh, Lord. Bigger numbers. I've got the whole numbers. I've also got 1/2 and 1/5. Definitely not a common denominator. So what am I going to do? Well, let's not panic. Let's first build our minuend here. 3 1/2. Okay. 1, 2, 3 1/2. Okay. 3 1/2. And we have to take away 1 1/5. Well, the good news is that we can take away 1. Boom. Yay. We did it. Well, there's a problem. I can't take a 5th from this half. I just can't do it. Let me get a 5th piece out and show you. These do not match. Not good. They are not the same. What am I going to do? Oh, my Lord. What do I do? Well, I'm going to have to find a way to break that half into something that is also going to work with the 5ths. So how am I going to do that? Well, let's see if I can do it with the 5ths. Maybe 1 I can't do, but maybe I can form 5ths with 3 of these 5ths. So I'm going to 5th here, a 5th here. Oh, man. You see how much that is over? Get over here, close to you. Look, I got the 1/5 and the 1/5, but if I add the other one here, it goes way over the half. So I can't do 5ths. That's not going to work. What do I do? Well, the rule is, what you need to do is you need to find something that both 2 and 5 go into so that you can break the 5th and the half into something that is going to be divisible by, both are going to be divisible by. So what is the smallest number that 2 and 5 both go into? Well, let's think about this. Yes, that is going to be 10. So how do I do that? Well, what I need to do is I need to figure out how many tenths I can fit into 1/2 and see if we can make that work here. So let's do this. 1, 2, 3, 4. Ooh, 5. 5 fits. Oh, I'm in luck here, kids. Look at that. Oh, yes. So it looks like my 1/2 is equivalent to 5 tenths. So let's bring that down. 3 5 tenths. But I have to subtract 1/5. But what is 1/5 equal to? Well, let's figure that out. Let's get out my 5th piece. Test here and see how many tenths go into that. 1, 2. Oh my God, 2, perfectly. Look at that fit. 2 tenths fits perfectly into my 5th there. So it looks like 1/5 is equivalent to or the same as 2 tenths. So now I've got something I can work with. It looks like now, let me get my half piece out of here because I've turned him into 5ths, or tenths, I'm sorry. All right, so I've got left, and let's bring this one back just to start over again. 3 and 1, 2, 3, 4, 5 tenths. And I'm going to take away 1 and 2 of those tenths. And whatever I have left over, I'm going to move over to my difference section here, and we'll see. So let's start easy. Let's take away the 1. And then let's take away 1/5. And we know that 1/5 is equivalent to 2 tenths. So we're going to take away 2 tenths. And the 2 tenths are going to go to our subtrahend here. And that is what we have taken away. What's left over here, I'm going to move over here, and that is going to be our difference. So here we go. Move, move, move. Okay. 1, 2, 3. And lo and behold, what I have left over is 2 3/10. And let's check that out. Well, let's subtract the whole numbers. 3 minus 1 is 2. And 5 minus 2 is 3. I keep the same denominator. When you add or subtract fractions, you do that. And I, in fact, do get the same exact answer as I got with the concrete, 2 3/10. So that is how you do subtraction without having a common denominator to start with. So let's think of another example that we can work with. All right, so that was success. Let's start again with a new problem. All right, so how about 5/8 minus 1/4? 5/8 minus 1/4. Okay, well, no whole numbers, that's fine. No big deal, but we don't have a common denominator yet. So let's put our 5/8 out there. All right, so these are my 8s. Okay. 1, 2, 3, 4, 5/8. Well, that's Pac-Man with a big mouth open there. Okay, so that's 5/8. 1, 2, 3, 4, 5/8. And what I'm looking to do is take away 1/4. Okay, and let's see if there's anything here that matches. Does 1/4 in fact match any of my 8s? Because I have to take this away. I have to take away 1/4 away from that. So does anything here match 1/4? Oh, I got lucky. 2 8s does in fact match 1/4. So 1/4 is equivalent to 2 8s. But I better write this down so I keep track of what's going on here. So 1/4 was 2 8s, so 2 8s, and I have the 5/8 minus 2 8s, and now I've got something I can really work with here. This one was pretty easy getting that common denominator, and I take the 2 8s and I put them over here. They're my subtrahend, and I move the rest over here to my difference. And what do I get? I get 3/8. So that's what I have left. It's the difference between the two. So that is an easier one. Let's do one more example. Let's do one using a couple of different ones. And with the fraction materials, you can do a lot, but if you have fraction insets pieces all the way up to 20, you can do even more interesting things. Let's do 2 2/3 minus, let's just have some fun. Minus 8/9. Let me see what happens here on our last example. This one may get really interesting here. So this one's kind of an adventure, but guess what? If you're not having fun, what are you doing? All right, so 2 2/3. Okay. And you got to take away 8/9. All right, so I'm going to build my 9ths here. All right, so 1, this is just an artificial build to show you what 8/9 looks like, because this is what I'm going to end up having to take away from one, 2, 3, 4, 5, 6. 7, 8. Looks like Pac-Man's not that hungry right now. He's facing the other direction. All right, so that is 8/9. All right, well, I got to take away 8/9, and let's see. First of all, let's start simple. Let's see if we can match these 9s to the thirds and see how many 9s go into the third. So let's take a third here, and let's see how many 9s go into it. It looks like, I got 3. 3/9 is equivalent to 1/3. Okay, so that means that I should break my thirds into 9ths and then go from there. So let's do that. So I'm going to take these thirds and I'm going to change them into 9ths. And remember, this is just my tester here. I'm going to change each of these into 9ths. So that's a third. Boom. Now I got to change another one into 9ths. 1, 2, 3. All right, so that is the same thing. So we've got 1 and how many 9ths now do I have? 1, 2, 3, 4, 5, 6 9ths instead of those 2 thirds. All right, so let me write that down. 2 and 6 9ths minus 8 9ths. Okay, you see that? All right. Wait a second. Problem here. How can I subtract 8/9 from 6/9? Oh, this is where things are going to get interesting. Well, let me show you what I'm going to do. It looks like that we're going to have to break one of these whole numbers. We're going to have to break one of these whole numbers into 9ths so that we can take more 9ths away. We can take away the 6, but we still have more 9ths to take away. We still have, we can take away those 6, but we still have 2 more to take. So what I'm going to do is I'm going to turn one of these whole numbers into 9/9 in a parent fraction, and then we'll go from there. So this is why this one is harder, kids, because we have to break a whole number down into the fractions here. So 1 whole is going to become 9/9. Okay, and this is actually a great example of one that the materials do really well. Not a hungry Pac-Man. Oh, you're done. All right, so there's 1 whole that has been replaced by 9ths. So now what we can do is we can, let's say that this one is now, how many 9ths? How many 9ths total do I have? 1 and 9 plus 1, 2, 3, 4, 5, 6. 1 and 15 9ths. Let's just go ahead and just start doing the subtraction here of the 9ths. All right, so are you guys ready? We're going to take away 8 9ths. So 1, 2, 3, 4, 5, 6. Got to take 2 more. 7, 8. I got my 8 9ths. Did it? Got a not very hungry Pac-Man there. Slightly more hungry Pac-Man there. What's ever left over with my minuend is now going to be moved over to become my difference. Let's move it. You've got to move it, move it. You've got to move it, move it. You've got to move it. All right, so we moved it over here to our difference. And now we shall see that we have 1 whole and 1, 2, 3, 4, 5, 6, 7 9ths. All right, let's see if that's going to be the case. This could be a colossal disaster. I don't know. That's the joy of doing this. All right, I took away 8 9ths though. 1, 2, 3, 4, 5, 6, 7, 8. Now, kids, I'm going to erase the subtraction part here and go over how I would do this in the abstract. So 2 and 6 9ths minus 8 9ths. So what I'm going to do here is I'm going to make what are called improper fractions. So when you create an improper fraction, you multiply the denominator by the whole number and add the numerator. So that's going to be 18 plus 6, I believe. It's 18 plus 6. I'm not sure if I'm doing that right. Well, let's try it. 18 plus 6 is 24 over 9 minus 8 over 9 gives us 24 minus 8 is 16 over 9, which, I think that's correct. I changed it to 24 over 9 minus 8 over 9. It gave me 16 over 9 when I subtracted them. Now I have to do what is basically a division problem. You divide the numerator by the denominator. How many times does 9 go into 1? None. How many times does it go into 16? 1. 16 minus 9 gives you 7. Oh, that's a terrible 7. So sorry. And 1, and then you have 7 left over, and that is equal to 1 and 7/9. It's so funny. This is one of those situations where the abstract way is not as compelling or as easy as doing it in the concrete. I love this. 1 and 1, 2, 3, 4, 5, 6, 7/9 is the correct answer. We got it with the abstract, but I did have to do some improper fraction work. Didn't necessarily anticipate it, but guess what? Got to have fun while you're doing work, and so I am hopeful you guys are following along here with this last example. You don't need it to understand what I taught you, but it was fun nonetheless. So a little bit extra for you. And for those of you that know improper fractions and how to work with them already, that's awesome. I saw what I was doing. All right, so we will be posting some follow-up activities for fractions on this one for you all. Kids, I hope you enjoyed this presentation on subtracting fractions. I know I did. It's a little more difficult in the concrete to sort of figure out exactly what you're doing at first, moving with the menuend and then building the subtrahend and then having the difference. But I do think that it is valuable to really work with those concrete materials to find out how subtraction actually works and to do it with fractions building common denominators. So thank you all for tuning in. I hope you had fun. I know I did. Bye.